I think it flew the coop. Ah, here it is. All right, we are now recording. Let me just go on and get this set up from current slide. We'll be ready to go when we do start really recording. For some reason, it's not going to current slide. There it goes. Now we can turn on the projector today. All right. This is Cougar Connection Week, and things that are happening. We're going to be on both campuses for most of the week. On this campus today is Constitution Day. Now, I don't know when Constitution Day really is, but it's sometime, I guess, around this week. And the activity for that will be in the faculty staff dining room, which is just this side of the cafeteria. And that will be from 12 to 1 today. And should be a pretty good program, okay? On the Birmingham campus, they've got Get On Board Volunteer Fair, okay? That will be outside of the library, and I assume that's when they say that, they mean the park sort of under that covered walkway there on the way to the administration building, and perhaps one side or the other on the green grass or in the courtyard in the middle. Just go there and you'll probably see all the activities. That starts at 8 this morning. Started at 8, which is unusual because classes don't start till 8:30, and it goes to 1 o'clock today. Here are some of the organizations that are probably have some type of representation there today. Ben Green Housing Authority. Oh wait, I'm sorry. Big Brother, Big Sister. Ben Green Housing Authority, Bassman Recreational Center, Faith Chapel, Girls Incorporated, Grace House, Hands On Birmingham, Humane Society, Metro Changers, Oaks on Parkwood, Operation Hope, Powership Network, and the Red Cross. Now, I believe they said the blood drive will be sometime next week. They couldn't schedule it for this week. Okay? Now, in addition to that, this is Saya. Okay. In addition to the volunteer organizations you can stop and talk with and see what you can do to participate, there's also student organizations, Lawson organizations, if you want to be a part of. Now, here are some of the ones that will be represented. Ambassadors, Athletics, Fine Arts, Honors College, PBL, that's Phi Beta Lambda if you want the full name, Scholars Bowl, SGA, Student Government Association if you don't know what that means, Speech and Debate, Student Support Services, and Science, Technology, Engineering, and Math, the STEM program. Now, what they didn't mention, and I wish they had, was the math club, math team. They're called the Prime Examples, or that's what the name they used to go by. And I don't know if they have a table or not, but if you're interested, see Miss Gerasi, okay, or any of the other math instructors. And that's today from 8 to 1, Birmingham West Campus. Tomorrow, before we meet again, it'll swap. It'll flip-flop. On this campus, it'll be, for some reason, 8 to 1. The same thing, all those organizations here. This time they'll be, if you know where the little courtyard is outside the library before you go to the B building, it's down the stairs from where you walk into the student services entrance here. There's a little courtyard down there. I think that's where it's going to be. It says outside the library, so it's either the parking lot outside or there. I think it's there. And that's 8 to 1 tomorrow, which I'm wondering if the people will show up at 8 if there's no students here until 8:30, but whatever. And then on the Birmingham campus, they have the Constitution Day program, and that will be in Thelma Catlin Auditorium. That's in the library building, Building D. And if you can't find it, just ask someone at the library. They know where it is. It's real close there, but it's pretty well hidden. And that will be 12 to 1 there. And then I'll announce to you Wednesdays and Thursdays activities on Wednesday. All right. Any questions about either what's going on campus or what we got going on in here. Now, let me say this, a big apology here. I did not get all your papers graded. I tried, but Friday was a madhouse over on the Birmingham campus. My boss wasn't there, so I had to handle all the traffic that came into the office, which was not that much, but advising students and things like this. And also, they wanted second mini-term classes open for, coming up second mini-term. Well, they had closed a couple of them. I don't know why, so I had to reopen those, and then I had to come up with a bunch of new ones, finding rooms for them. And I know that the vast majority of those will be canceled, because they always are. But they required us to do that. And between instructors and others coming by, it was a madhouse. Lexi's here. And huge, right? Yeah. Had to find me on the roll book. Anyone else come in since I called roll? All right. So I got just a few papers graded in between other things that were going on, and over the weekend it was just about as bad at the house. I mean, we had stuff going on all weekend long, and I've got easily 2/3 of them done, but not quite all of them done. So sorry about that. And they're not on Blackboard, those that I have gotten done, so as soon as I can do it. Now, I have 4 hours of office hours this afternoon. I hate to say that because I'm afraid something's going to occupy most of that, but I do know that I've got 2 reports that I've got to get in this afternoon, so they will occupy, but hopefully they won't occupy that much time. And then after that, as we'll talk about today, we're awfully close to quiz time, so I'm going to have to be making up a quiz too, and getting your papers graded. And I've got a few other papers to grade too, so it's going to be a full afternoon. Any questions before we get going on today? Now, my mark, even though the PowerPoint slide said we were further along, my mark was that we were right here, left off, and this would have been last Monday because we had the test on Wednesday. Okay? So, y'all remember that far back? Is this about where we were? Okay. All right, we were just going to talk about factoring trinomials of the form x squared plus bx plus c. Okay? And where b and c are always integers, and they could be any integer. Okay? Here the b is 9 and the c is 14. Now the trinomials, I think I showed you how I would do this. Okay? And rather than look at this, let's talk about it. Okay? What's the only possible factorization for x squared? X times x, right. Okay? Then the next place I look, I unfoil it. So let's go to the third term, the last term. I don't spell it right. Okay? And the sign of the last term is positive, which means what? These two signs here, x and x, following them would have to be the same. They don't have to be positive, they have to be the same. But since this one's positive, they both have to be positive. So you're right, they have to be. Then the final thing is what two numbers multiply to be 14 and add to be 9? 7 and 2. Okay? And that's exactly how you factor this. Okay? Say showed it all, which I regret them doing. I think it's better to do. So what I was just describing was hope that it factors. You don't know that it will, but hope that it does. If it does, break the first two, x times x. And when it's in this form, there's always going to be your first two factors. That's what makes this form so easy to factor, if it's factorable. And then it becomes the plus and the plus. And then the two numbers that multiply to be 14, add to be 9, be 2 and 7. In either order you wanted to write it. You could put x plus 7 times x plus 2. That doesn't matter at all. Does that make sense? All right. Pretty easy going. They have a technique which works really, really well, but it's just a lot longer, okay? And, but let's see. The method by which these factors of a trinomial are found is based on FOIL. That's why I call it unfoiling. Okay, in the trinomial, x squared plus bx plus c, the coefficient of x is the sum of the constant terms, the coefficient of x, sum of the constant terms in the binomial. When you do x plus something or x plus something, whatever, the sum of these has to add to be this coefficient. Exactly what we said. In the trinomial, okay, the constant term is the product of the constant terms in the two binomials. When you factor this, x plus something, x plus something, x minus something, x minus whatever it is, then the sum of these two make the constant term in the trinomial. Okay? What we've already said, this just puts words on it that to me make it a little more confusing. When the constant term of a trinomial is positive, the constant terms of the binomials have to have the same sign, which is one of the first things I look at rather than doing the other part first, okay? And they will have the same sign as the middle sign here, this coefficient of the x in the trinomial. And when the constant term of the trinomial is negative, and this is a negative, then one of those is positive, one's negative. And then you have to figure out which one it is. They will have opposite signs. So that's the kind of stuff we think about. In those words, I'm not sure. In that order, I'm not sure. But those are the type of things we think about. Okay? Now, let's factor this one. Much more direct here. Now, in the book, before we start doing this, they do give a couple of more examples before we get here. In fact, they do quite a few more. So let's do, there's not really room on that page. We'll do it on this page. Okay, we haven't gotten to that one yet. Let's do these. X squared minus x minus 12. Okay, is that going to factor? We don't know, maybe. Let's give it a shot. What would be the only possible factorization for x squared? X times x. That was easy. Okay. Now we look where? Where did our attention go? Sign of the last term. What is it? Negative. What does that tell you about these two signs? They're what? They're opposite of each other. They're not the same. One's positive, one's negative. And it doesn't matter what order you put them. Doesn't matter at all. Okay, now this time, here's my little rule that the book doesn't do. Now we're looking for a number that multiplies to be minus 12. It's got to be minus because the sign's right. But now, because they're different signs, the difference of these two numbers has to be a minus 1. Different signs, the difference of the two numbers. Okay, so two numbers that multiply to be 12, and their difference is 1. Two numbers multiplied to be 12, difference of 1. Yeah, 4 and 3. Now, to which one do we assign which sign? S-I-G-N sign. Okay, so 4 goes with the minus because 4 is larger than 3. The minus sign wins. Okay, so that's what we do. Put the 4 with the minus sign and put 3 with the plus. Okay, whichever sign is going to win up there. Now, this won't always work in the later times, but when that is an x squared, this works just about every time. Okay, now, if you don't remember all those little rules, just pick any two numbers, put them down, FOIL it, see if you get them right. If you don't get them right, if the number's wrong, change numbers. If the sign's wrong, the number's right, but the sign's wrong, just change signs. It's really easy, okay? So that's how we do that one. Let's try another. X squared minus 2x minus 15. Okay? Now, we don't know if it's factorable, but let's hope that it is. What would be the only possible factorization for x squared? X times x, right. Pretty easy. Where do we look next? sign of the last term, and what is it? Negative. What does that tell you about those two signs? They're opposite. They're different from each other. Which order you want them? I don't care. Plus, minus. That's fine. Okay? Now, what we're looking for now is the product of two numbers that will be 15. Don't worry about the signs now. They're taken care of. Product is going to be 15, but because they're different signs, the difference is going to be 2. Product 15, difference of 2. 5 and 3. Which one wins the minus sign? 5 gets the minus sign because the minus sign wins here, okay? And the 3 here. Oh, I forgot to check it. Always check them. X times x, x squared, that works. Then you do the outwards, and that's minus 5x plus 3x is minus 2x. That works. And then minus 15. Yes, we're so happy we drew a smiley face. Okay, got it. Any questions on that? All right. Now I think I'm ready for their... No, they still have a couple more examples here. Well, what they do next is a bunch of multiplying of binomials, which we know how to do, right? You need to practice doing those. You want to see a few of those? Yeah, we got them down. Okay. So we're not going to mess with those. Now, here's one more before we get to the one here. Here we have an x squared minus 2x minus 24. Okay? How would you begin? X and x. Okay, y'all got that down. Okay. Next. Plus and minus. You got that down. Excellent. Okay. Now what are we looking for? We're looking for someone to come to the classroom. And here we have, can you help me with the name? Huh? Johnson? Okay. Kylie, right? Okay. Okay. And for those who just came in, I did not get to finish grading all your papers over the weekend. I got about 2/3 of them graded, but it just was a crazy weekend. Friday was nuts from the Birmingham campus. I had hoped to get them graded there, but I couldn't. But anyway, I hope to get them graded. And none of the ones I've graded so far I don't think are on Blackboard. Maybe the first few of the earliest ones might be, but most of them are not. Okay, we were doing this one, x squared minus 2x minus 24. We had determined x times x. We had determined plus times minus. And now what are we looking for? Two numbers, two factors that multiply to be 24, but because they're different signs, their difference is 2. Second? 6 and 4. Which one goes with which sign? 6 with the minus because it's the larger number, and the minus wins up here. 4 down here. And we can check it. X times x, sure enough, is x squared. Minus 6x minus 4 plus 4x is minus 2x, and minus 24. Yes, yes, yes. All right. Any questions? Okay. And they make a point of it doesn't matter which order you do this. You could do x minus 6 times x plus 4. Same thing. Multiplication is commutative, so it doesn't matter which order. All right, now we're going to erase all this. Anyone need it a little bit longer? Okay. Now let's do this one. How would you begin? We begin hopeful, hoping they will factor, okay? And what do we do? X times x plus plus. Because the last term's plus, that means these two have to be the same. Because the middle term's plus, they both got to be positive. And now what do we look for? 16 and 2. Okay, two numbers that multiply to be 32, and this time add to be 16. Okay, so that would be 16 and 2. Let's check it. X times x, sure enough, is x squared. Plus 2x plus 16x, that's plus 18x, plus 32. Got it. Happy campers. Any questions? Make sense? Now, I meant to show you, I don't want to show you how the book did it, okay? Okay, it's a long and drawn out process, and I will show you that process a little bit later. But on these, it's so easy to do it this way. Why introduce a lot longer process? But if you want me to, I'll show it to you. It's, okay. And when it gets time, we will. You can read it in the book, and if you like this better than what we're doing, go for it. It's right. It's absolutely correct. And if you like it better, do it. Now, we just did focus on factoring a trinomial that's followed by a check your understanding 1. Does anyone need to see another one done like this? No. Okay, then do your check your understanding. Those of you who are in the tutorial thing that goes on down the hall here, if you're going in right away, do these check yourselves first, okay? If you're not in one of those, or yours isn't until later in the week, do these soon, as soon as you can. So let's move on to focus on factoring a trinomial 2. Well, I'm sorry. Let's first see how they did it, okay? Here it is. They're going to show it to you anyway. Okay. What they do is do all the factors of 32. 1 times 32, 2 times 16, 4 times 8, and then if you keep going, you get 8 times 4, but that's the same one. Okay, now, the other thing to notice, because the signs have to be the same, the sum is positive, so both of these are positive. Well, these had to 33, not 18. Forget it. These had to be 18. Bingo. Oh, can't say that in Alabama. But, yes, it works. So, therefore, that's the one. You don't even have to go down here to 4 and 8, because that doesn't add to be 18. Okay? That's the way they do it. A little bit longer, but it's kind of sailor-proof or student-proof, you know, that it should work every time. There will be a later time when we almost have to do this kind of thing. And we'll wait and do it then if we need to, okay? And it is a good technique. If you want to use it, use it. It works, okay? We chose 2 and 16, so now we put the x plus 2, x plus 16, and then you can check it, and sure enough, it gives you x squared plus 18, x plus 32. And they don't even do it with a smiley face, so I don't know what's wrong with them. Okay, any questions on that? Does the same thing we did, a little bit longer, but maybe if you like doing and seeing every step of the possibilities, go for it. It works. Any questions? All right. Now, I'm trying to find, they've skipped over and are not doing focus on factoring a trinomial 2. So let's do that. This time we're going to factor x squared minus 6x minus 16. Okay? How would you begin? X times x. Y'all got that down. Plus and minus. Excellent. And what are we looking for now? Say again? 8 and 2. Who wins which side? 8 goes with the negative, and 2 goes with the positive. Does everybody see what we're doing there? Why we're doing that? Okay. You know it's got to be 8 and 2 because this multiply to be 16, and their difference, because they're different signs, has to be 6. So 8 and 2 works. Okay? Now, what we're doing here, which one goes with plus and which one goes with minus? Well, the larger of those two numbers needs to go with the sign that you see here, because that's the sign that wins. Okay? So the minus 8 goes here, the plus 2 here. Because when you do your foiling to check it, x times x is sure enough x squared. And then you get a minus 8x plus 2x. That gives you the minus 6x. That's why you have to have the one with the larger number, the sign of the middle term. when they're different signs. And then you have finally your minus 16. So that works too. All right. Any questions on that? In the book, they carry it through and show you all the possible factorizations of 16, and it has a lot. 1 and 16, 2 and 8, 4 and 4, and they, and then they throw in the signs, okay? And when we get there, I'll show you an easier way to do it with the signs. So you don't have to try all the different combinations. But we don't need it yet. If you have any questions about it, ask me. I'll do it anytime. Any questions now? Okay. That's followed by Check Your Understanding 2. So if you need more practice on this, I'll do it in class if you want to see it, or you can practice on it as soon as you can afterwards. All right. Now, the next slide. Well, we already did these. Okay. Not all trinomials can be factored when using only integers. Okay? Let's do this one. Okay? What would be our possibilities here? Tell me how to start. X times X. I like it. Next? Plus and minus. And then you're looking for? To multiply to be 8, but whose difference is 2. That's 6. Say again? 2 and 4, they multiply to be 8, but the difference isn't 6. Okay? 1 and 8, multiply to be 8, but the difference is 7, not 6. So in other words, none. Not factorable. Okay? Now they listed them all out here, and frankly, they listed twice as many as they needed. But if you're going to do this, here's what I suggest. Factors of minus 8. One of these got to be positive and one's got to be negative, right? Which one's going to be negative, the larger or the smaller? The larger, because you wind up with the minus in the middle. So therefore, I would never even put these down here, okay? So you got 1 and 8, 2 and 4, but then after that it's 4 and 2, and 8 and 1. That's all, folks. When you add those together, you get minus 7. Add these together, minus 2. Neither of those is minus 6. Not factorable. Okay? Because none of those has a sum of negative 8. The trinomial is not factorable using integers. Trinomial is said to be not factorable over the integers. Okay? On the quiz or test, if you want to just say not factorable, fine. Okay? Now, let me, though, make a little distinction here, okay? Not factorable means you cannot, no, it cannot be factored. Not factorable doesn't mean I can't factor it. That's not going to be a right answer, okay? I don't care. I mean, if it's factorable, okay, you got the idea. Okay, so that's not going to be a legitimate, oh, I can't factor that one, not factorable. Oh, but I couldn't factor it, so it's not, no. It means it can't be factored, not you can't factor it. Okay, never mind, that was dumb. And that is it for the that part, okay? There are some practice problems, 1 through 5, top of page 8, okay, module 11, page 8, okay? 5 of those, please do those, okay? Check your understandings, all those first, then do the practice problems. And if you're going to those tutoring sessions, that's what I recommend you focus on. All right. Any questions? All right. Now we're going to get to something I've been alluding to, but we haven't actually done, and that's 11.2B, or not, okay? And this is, let me get my setup from the current slide. Factoring polynomials, I'm glad they used another slide for that. And then 11.2, factoring polynomials of this form, used another slide for that, same thing we had before. And this time it's 11.2B, factoring completely, okay? Now, I've sort of made reference to it before, but told you you're okay for now, Now you're not. Okay, now you're going to have to always check to see if you can ever go further. A polynomial is factored completely when it is written as a product of factors. Each of those products non-factorable over the polynomials. So you're going back to what we just did, non-factorable, but you got to get each factor until it's factored down until what you have left is non-factorable any further. The first step in any factoring problem is to see if that polynomial has any common factors. Always, always, always do that first. Okay? If they do have common factors, factor it out first, then deal with the rest of it. Okay? Otherwise, it's a lot harder. And I'm lazy enough, I don't like to do it hard way. Do it the easy way. Get that common factor out first. You're not going to see sometimes what other possibilities are until you get that common factor out of the picture. Okay? So how would we begin on this one? Oh, yes. Common factor. Let me get my pen back. Okay. Not back yet. There we go. Common factor of 3x. Okay. What's left? X squared plus 5x plus 6. Is that what I heard? Okay. Okay. We factored out the monomial factor. We don't have to do anything else with those. They don't have to be completely factored. We just leave it as a monomial, 3x. But we have to ask ourselves, can that trinomial be factored any further? Yay or nay?
Yes, sir.
Yes, how?
3 and 2,
X times x plus 3 and 2. Two numbers that multiply to be 6, add to be 5, 3 and 2, there it is. Now those are all non-factorable. We have factored it completely. Got it? Does that make sense? Good deal. Okay. You want to see how they did it? Yes, you do. Besides, I have to go through the slides anyway, so you're going to look at them anyway. Okay. All right. First, greatest common factor, GLC. Okay. That stands for Great Charles Fowler. No, it doesn't. Okay. Greatest common factor. Okay. Those three is 3x, which y'all picked off right off the top, which is good. Factor it out of there and see what they write in an extra line or two. That's wonderful. Okay. Factor out the 3x, and that leaves you an x squared plus 5x plus 6. Are you through? Not until you check and see if that's factorable. And sure enough, here's their table again. Possible factors for 6, be 1 and 6, 2 and 3. These had to be 7, not right. These had to be 5, absolutely correct. Okay? So we use 2 and 3. Okay? So it's 3x times x plus 2 times x plus 3. Now, you check it by going back and I would always FOIL first, and they almost got it done. That'd be x squared plus 5x plus 6, and then multiply by 3x, and that would be 3x cubed plus blah, 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 blah. Well, here, they're going to do it in gory detail. 3x cubed plus 15x squared plus 18x, which was exactly what we started with. All right, any questions? Okay, and that was it for this one. Let's see if there's any more in the text. There's a check your understanding, which certainly needs to be done, and they sort of threw an extra little thing in there, extra variable. Be sure you get those out of there too. And then they skipped the next one. So let's go back and we will do the next focus. All right. X squared plus 9xy plus 20y squared. Okay? What do we usually check for first? In fact, always check for first. Second? Common factors, is that what you said? Okay, say yes. Okay, good. All right. Common factors, okay? Do you see any? Okay, you have an X here and here, but not there. They have to be everywhere. Okay? So no, there is no common factor. So where do we go from there?
Unfold.
Unfold it. Let's see what we can do. Okay. What's the only possible factorization for x squared? X times x. Y'all got that down. Then what's next? A little louder. Plus, plus. Okay. Now, what we're looking for, possible factorization of 20y squared, which basically is going to be something times y, some number times y. They multiply to be 20y squared, but add to be 9y. Forget about the x here, that's taken care of. 9y.
That's 20y squared.
Say it again. This number here is 20y squared? 20. Yeah, she's making fun of my writing, I can tell. But I'm not hurt at all by it. No, I can handle it, sort of. Okay. Say again.
5 times 4 is 20.
Okay. 4y times 5y would certainly look like it would work. So let's try it. 4y, 5y. Okay. Let's check it and see. X times x. X squared, that works. Plus 5y, xy, plus 4xy, that adds to be 9xy, right? And then 4 times 5 is 20, y squared. Yes, it works. Now, the question is, can you take it any further? No. Nothing else you can do. So why is this example in this section? I don't know, okay, except just to give you two variables. Okay, it didn't factor. It did factor completely, and that's all she wrote. Okay. Now they drug it out an extra step or two, but theirs works well too. There's a check your understanding for problem there. The solution's all over on page S2. That's the supplementary for this section 2. And then the practice problems are 5 of those. Please do those. And those answers are over on page S7 in this section, this module. All right, any questions on those? Okay, if you need to see any more done, I'll do them, okay? Just let me know. Slow me down, stop me, or we'll carry on. Carry on, okay. If you ever think it's going too slowly, just let me know, and I'll keep going at the same speed. No, I didn't say that. Okay. All right. So let's go now to 11.3A. We're getting awfully close to quiz time for Module 11. I don't have it ready yet, but I hope to have it ready on Wednesday. So you'll have the weekend to play with it. All right. Factoring trinomials. That's new, isn't it? Okay. Current slide. Okay. Module 11, factoring polynomials. This now, we're going to be factoring polynomials. Oh, boo hiss. Now we have a coefficient for the x squared. Boy, it was so much fun when that was only an x squared. Answer the first question, x times x. It was always that, okay? But now we have an a in there, okay? So it's just going to make it just a wee bit more difficult, okay? Not really all that more difficult, just another step or two. But that's the difference between 11.2 and 11.3, that little a. So objective 11.3a, factor trinomials of this form using trial factors, okay? Basically, that's how I like to do them anyway. They're going to show you another technique, and we'll go through that too, but we'll first use trial factors, and that's what we do. So trinomial of this form, ax squared plus bx plus c, a, b, and c are all integers. Now here, it can't be just any integer. B and c can be any integers. A can never be 0. Any idea of why that would be the case? If a is equal to 0, you have a linear equation. And that's really easy to do. You don't factor it at all because it's linear, okay? Unless it's a common factor. So a just can't be 0. All right. So here's our 3x squared minus x plus 4. A is the 3, b is the minus 1, and c is the positive 4. As if you could figure that out, okay? Now, how do we do it? Same way we just did. We unfoil it, except this time the first question is easy. It's not always x times x. Okay? Let's see if we can do this one. They're not doing it, but let's see if we can. Let me get my pen back. The first question is still the same. What's the only factorization of 3x squared? 3x times x. You got it. See, it's not a lot different. Then we look at the where? Sign of the last term, and that tells you those two signs have to be the same. You look at the middle to see what they have to be. Minus, minus. We didn't have one of those before. Okay? Now is where we have the difference. Okay? Before it was really easy. We had to get two numbers here whose product was this, whose sum was this. Not anymore, because those x's have different coefficients. Okay? So we have two numbers that multiply to be 4, and when you combine them with this, they add to be 1. Okay? Which is kind of impossible, isn't it? This is, guess what? Not factorable. At first I thought it was, but it's not. Okay? Not factorable. So what a nice one to lead off with. But they didn't do it. They just said this is what this form is. But that one's non-factorable. If one of these had been a plus and one a minus, then it would work. But then that wouldn't have been a plus there. So this one's non-factorable. Okay? No matter what you put in for the 4. 1 times 4, not going to work. 2 times 2, not going to work. Nothing is going to work there. Okay? So, sorry, we shouldn't have even tried. But it's one that's non-factorable. Okay. Not just that you can't factor it, but it's non-factorable. All right. All right. Here are their little points to remember. To reduce the number of trial factors, remember the following points. If the terms in the trinomial have a common factors, always, always, always look at that first and factor them out. Okay? If the terms of the trinomial do not have a common factor, then the terms of the binomial factor cannot have a common factor. Okay, that's why. Okay. When the constant term of the trinomial is positive, the constant terms of the binomials have to have the same sign. We just saw that as the coefficient x. And when the constant term of the trinomial is negative, the constant terms of the binomials have the opposite sign. We've already done that. Okay? The first step in factoring a trinomial is determine whether its terms have the common factor. Always look for that first. If so, factor out the greatest common factor from the terms and then proceed with the rest of your process. So, where do we begin here? A 3x squared? Okay. Comes out, you said. I can see there's a 3x squared in here. Oh, no. Okay. Second? Just x. But factor it out. Okay? What's left? 3x squared minus 23x plus 14. Okay. Now, don't forget the x. It's there. It's a factor. It's just going to hang around for a while, but let it hang. Okay. Now, where do we go next? Only possible factorization for 3x squared. 3x times x. Right? All right. Where do we look next? Sign of the last term is, what does that tell you about these two signs? Have to be the same. What sign do they have to be? Negative and negative. Very good. All right. Now here's where the trial and error comes into play. You come up with some possible factorizations for 14. We'll try them out. See if they work. Come up with one. Did you say 2 and 7? Yeah. Okay. Let's try it. 2 and 7. Okay. Now let's do our foiling. 3x squared. That works. Look at you. Minus 21x. Minus 2x. He is smiling. Okay, that's minus 23x plus 14. Yes, it does work. Okay, 2 and 7 right off the bat worked. Okay, so therefore, there's our complete factors. Can we factor anything any further? No. Okay, we are done. Okay, see how it works? Come up with any factor. Now, again, what if you hadn't gotten the right answer there? You had done 7 and 2. 7 here, 2 there. That would not have given you the right answer. When you didn't get the right answer and the number was wrong, change numbers. If the sign was wrong but the number's right, change signs. Well, these are the same signs, so that's not going to happen here. But the numbers could have been wrong. But y'all got it first shot. That took all the fun out of it, didn't it? Okay. I should have been paying closer attention to this. Let's see. They give us a couple of other examples. Let's just see if that second one they give us. That first one, the 3x squared minus x plus 4. All they showed that was for what's your A, B, and C. Let's do that next one, see if that will factor. 4x squared. This is in the book on Module 11, page 9. 4x squared plus 5x minus 8. Oh, this should be fun, shouldn't it? Okay, what do we look for first? Common factors, we got any? Nope, unfortunately not. All right, this is going to take a bit more work, and here's why. Notice there isn't just one possibility for how to factor 4x squared. Here there was. 3x squared is only 3x times x. But 4x squared, it could, that could be x times 4x or 2x times 2x. Okay? And when you look at your last term, it can be 1 times 8, 2 times 4, 4 times 2. And then you've got all the sign changes. Oh my word, this could be more difficult. Now we use a method similar to what they do because this has way more possibilities. It's called, I like to call it the AC method. I don't know if this book calls it that or not. Remember what our A and our C is? What's your A? What's your C? Minus A. Okay, don't forget the sign. Okay, and A times C would be negative 32. Okay? Now this is a little bit longer process, so hang with me and see. B, by the way, is 5. Okay, just note that. Now what we're going to do is all the possible factorizations of your AC, that negative 32. Now, what can you tell me about the factors of negative 32? Just right off the top, what can you tell me? One's going to be plus and 1 negative. What's the B? Positive. Okay? So therefore, the bigger number here has to be positive. Okay? So, we're always going to start with the minus and then the big one's going to be positive. So we're going to write down the various factors. Minus 1, positive 32. Does that add to be 5? No. Okay, forget that. Minus 2, what would that be? Positive 16. Does that add to be 5? No. Forget that one. Will 3 go into 32? No. 4? Minus 4 plus 8. Okay. Does that add to be 32? Add to be 5? No, it adds to be 4. And guess what? This is not factorable. Why? Because this added to be a positive 31. That added to be a positive 15. Both of those are too big. This added to be a positive 4. That's too small. There's not one. Okay? So right there you can say not factorable. Okay? When you have these that have so many. If you started trial and erroring the hat, you're going to be going for a while. So AC method sort of streamlines it. So why do I use it? It's easier. I'm lazy. Okay? I want to go for the easiest method. So this is not factorable. So neither of those were factorable. Shame on them for doing that to us. Okay. And we did. Okay. We've already done. Goodness gracious, I should follow the book a little more closely. This one that we did on the slide set, I don't see anywhere in the book, do you? Yes. Yes. It was way down, several pages away. Okay, I wasn't paying attention to the book, sorry. So, we'll go on and show how they did it. Then we'll come back and do the rest of them, okay? Same as we did before. Greatest common factor is just the x. Y'all pick that out. Factored that away. And then they did their little table. We did it without the table. And we got the same. Oh, they showed all those trial factors. Isn't that wonderful? But only one of them worked. So therefore, that was our factorization. Same thing we got, right? Okay. Now, they checked it. Good for them. Okay. Good. Got it. All right. And that was the end of the slide set. So let's us go back and do some of the earlier ones. Sorry about this. I wasn't paying attention. Here's one. This is on page 10, module 11 in your text. Okay. 10x squared minus x minus 3. Okay? It's the first thing we look for. Common factors, do you have any? No. Okay. So then we have to do our trial and error. Now, the bad news is the 10x squared has several different factorizations, right? The little bit better news, the 3 doesn't. There's only one possible factorization. Okay? So this time we're kind of do it really backwards. But before we jump to there, what do we do with their signs? We don't have either term in here. I'll put something here. I know there's going to be an x. I know there's going to be an x. Okay? There may be coefficients in front of them, but we'll leave those alone for now. I left room for them if we need them. Plus and minus, okay. Now, what's the only possible factorization of 3? 3 and 1. You want to put it in that order? Okay, we'll put 3 and 1. Okay? Now, what are some possible factorizations of 10? 5 and 2. Let's try 5 and 2. Okay? And let's see what happens. 5x times 2x is 10x squared. Got it. And then you have a minus 5x plus 6x. What does that give you? Second. Minus 5x plus 6x. All right. Plus x. Right? Now, what's wrong? Ours is a minus x. Wrong answer, but don't get too carried away here. Let's just get rid of our almost smiley face because it didn't work. We only are missing it by a sign. So therefore, let's just change the signs. Make that the minus and make this the plus. And now let's see what happens. Okay? You see what I meant? If the sign is the only thing wrong, change sign. If the number's wrong, change your numbers. But this was a sign wrong. 5x times 2x is 10x squared. Got that one. This gives us a 5x minus 6x. That's negative x. Got it. And then negative 3 times 1 is minus 3. That works. Okay? We have it factored. Does that make sense? Now, you can do the way they do, which is the table and all the possible factorizations. It works. It definitely works. This is a little bit shorter, okay? But their method, or what I call the AC method, is almost necessary when you've got bunches of different factors for the first term and bunches of different factors for the last term. Then by all means use AC method, and we'll talk about that a little bit later, okay? More a little bit later. Can I go to the next one? Is this making sense? If you have questions, please don't sit there with questions. Ask the question, okay? I think I told you this one before already. When I was in the Navy, which they weren't the cut it out here, okay? You went to Navy schools, and Navy schools aren't known to be all that great, but they're cut it out. Okay. Now, he's Army, by the way. Okay. The one thing that I heard in, I think, every Navy school I ever went to, I went to several, they had this little saying: there's no such thing as a dumb question except for one. That's one that you don't ask. Because if you have a question and you don't ask it, that's dumb. Okay? But if you ask the question immediately, it doesn't become dumb anymore. Because, and here's what I add to that, if you have that question, the odds are there's at least half the class that either has that same question or haven't even thought about asking it. Okay? So please, don't sit there with a question. Please ask it. Because you're helping your neighbor as well as helping yourself. All right, so don't let me just run on and on here and think, well, everybody's getting this, I must be out of it. No. Ask. Okay, 4x squared minus 27x plus 18. Okay. What do we try first? What do we always look for first? Common factors. Do you see any? Man, I wish there was one. Those are big old numbers, and I want to get some common factors out of there. There aren't. 4 only has 2 and 2. Never 1. I mean, 1's always common factors. We don't even play. 2 times 2, 27 is 3 times 3 times 3. No common factors there at all. Okay? So therefore, nothing to help us there. Now, what's the next thing you might note? Several factorizations here, several factorizations there. So this might be a good candidate for the AC method. So what's your AC? A times C. Ooh, big number. 4 times 8 is 32. Carry a 3, 72. And what's your B? Negative 27. Okay. So we want 2 factors for AC that add to be B. 2 things that multiply to be 72 add to be negative 27. What does that tell you right now? If they multiply to be 72,
They're both going to be negative.
they both got to be negative. Because to multiply to be positive, they both have to have the same sign. To add to be negative, they both got to be negative. So it's going to be minus minus. So I'm going to start, and just write that down. Now, let's start with the smallest one. 1 times 72. That's not going to be 27, right? Nowhere close. How about 2? Negative 2 times negative 36. Hey, we're getting closer. You see, this is negative 73 out of the picture. This is negative 38. Much closer. But still, no cigars. Okay? What's the next number will go into 72? 3. What would that be? 20 what? Negative 24. Believe that's right. What does that add to? Negative 27. Stop the presses right there. We found it. Now, we never got to this point before because last time there was no possible factors. What do we do with that negative 3 and negative 24? We go up here and split the minus 27 and write this as 4x squared minus 3x minus 24x plus 18. Now that looks like we made it more complicated, doesn't it? Okay, we went from 3 terms of trinomial to 4 terms of quadnomial or 4-term polynomial. So that looks like we are heading in the wrong direction, except for this. What do we do if we have an even number of terms? More than 2? Grouping, excellent. So let's group these 2 and those 2. Remember, that's not a factorization, that's just a grouping. What do we look for in the groups? Common factor. You see it in the first group? X times 4x minus 3. All right? In the second group. Now, when the second group leads with a minus sign, I always pull that minus sign out. So what do we have? Common factors in the second group. Negative 6. Pull the minus out. What do you have left? 4x minus 3. Ding, 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 ding. Looky there. Now we have what? A common factor of 4x minus 3. And what do you have left? X minus 6. Okay? And guess what? We can go back and check it. 4x times x, 4x squared, minus 24x, minus 3x, minus 27x, and plus 18. Yes! Whoa! All right. You don't have to check it, but I like to check it because as many as I make, I don't like making mistakes, okay? So if I check it, I can maybe catch those mistakes before I leave them hanging there, okay? Does that kind of make sense? There's where their table comes into play, and I think it's really useful here, okay? But you do it with the product A times C and the B in the middle, and then you do your checking those. And determine your signs up front. You can do that, you know, and then start with the smallest numbers and watch your numbers on the right. They should start one way or another and get closer and closer. If they skip negative 27, then it's not going to be factored. If you're following a regular pattern. Boy, my wife tells me I'm really, I knew this beforehand, stayed in rule bound. I follow patterns, you know, and you could just start guessing numbers, but then you never know when you finish guessing them all. Follow it directly. 1, 2, 3, 4, 5. You know, as many. 5 won't go into 6. You know, you're usually going to find it rather, I think, sort of quickly. All right. Any questions? Any questions? Don't sit there on top of a question. All right. That was the B part from there. And they showed this in the book, but didn't show it in the slide set. And they came up with the same answer. Good for them. Okay? I forgot to check to see they did on the other two, but they did. Now, the next focus. And this is the one we skipped. I skipped. I wasn't paying attention. Let's do the next, their first focus here. Here's the problem. 3x squared plus 20x. I said 20x and wrote 2x. What's wrong with that picture? Okay. Plus 12. Okay. What do we look for first? Common factors. Does it have any? No. Sorry about that. I wish they did. I'd like to get those numbers smaller, but we can't. So then what do we try next? Say again? We can do AC method? Certainly can. You want to do that? Fine with me. Want to do it? Okay, what's your AC? 36. And what do you do next? B is equal to 20. Okay? Now, what does that tell you about the SIGN signs? They're going to be positive, positive. Okay? So let's start with the smallest. 1 times 36. Add those. 37. Okay? not work, okay? Not 20. Next one. Next one. 2 times 18. What did I add to? 20! Look at there, hit it right there. But what do we do with that? Let me go back and take out my parentheses. I was going to do trial and error, but AC is perfectly fine. It got there in 2 steps, okay? So what do we do with the 2 and the 18? Okay, that middle term. Keep the first term, 3x squared, and then you write down plus 2x plus 18x. That adds to 20x, and then plus 12, okay? And what do we do with the first term? Oh, what do we do next? We group. We don't group, we group. Okay, here. What do we do now? Okay? And what common factor do you see? X times 3x plus 2 plus 6 times 3x plus 2. Ding, ding, ding. What do we do now? 3x plus 2 is a common factor. 3x plus 2. And what is left? S plus 6. Oops, not x plus x. See? What is wrong with you folks? You know, you must be too early in the morning for you. Okay. Now, let's check it. She checked her watch. Okay. 3x times x, sure enough, is 3x squared. 3x times 6 is 18x. Plus 2x is 20x plus 12. Yes, yes, yes. Okay. We've checked it. It works. There's your factorization. All right. Does that make sense? Okay. After that one, there's a check your understanding. If you need it, we'll do it. Otherwise, do it as soon as you can outside of class. All right. There's another focus on factoring they skipped. So let's get that one done. Okay. 6x squared minus 5x minus 6. What do we look for first? Common factors, is that what I heard? Okay, I hoping that was any of them? Nope. Sorry. So what method do you want to try? AC. Both of those have multiple factors. I think it's a good idea. What is your AC then? Negative 36. And B is negative 5. Okay? Now, what does that tell you? One's going to be positive, one's going to be negative, and which one's going to be which? One's going to be big and one's going to be small. Which is going to be positive, which is going to be negative? The big one's going to be negative. You got it. Okay. So, let's start with the small will be positive. That'll be 1 and negative 36. Is that going to work? No, that's negative 35. Nowhere close. Next. What's after 1? 2. All right, 2 will go into 36. How many times?
18.
Yeah, I didn't say the negative. Negative 18. You add those together and you get negative 16. Still no cigars, okay? Next. 3. Negative 12. What does that add to? Negative 9. We're getting closer, but still not there. Next. 4. Negative 9. Negative 5. Ding, ding, ding. We've got a winner. Okay. All right. And what do we do with it? We, split the middle term. Keep the first term, 6x squared. Say again? Plus 4x minus 9x minus 6. Got it. Now what? Group. Okay. Now, even though that looks like it's factorization, it's not. Those are just grouping symbols. What do you notice in the first group? There is an x. 2x. And what's left? 3x. Second? Plus 2. Excellent. In the next group, negative 3. And what's left? 3x. Plus 2, because you pulled the minus out, remember? Okay. Plus 2. Okay, very good. Now what? Which is 3x plus 2. And what do you have left? 2x minus 3. Let's check it and see if it works. 3x times 2x, sure enough, is 6x squared. Minus 9x plus 4x is minus 5x. And minus 6. Done. Yes. That is taken care of. Oh no, you can't tell me. We're already out of time and we're just having fun. Okay. Let's see where we left off this. Whoa, okay. This one was the top of page 12. Okay, there's a check yourself 2. Go on and do that one. We got their answer. 3x minus, and they wrote it in different order, it's fine. 2x minus 3 times 3x plus 2. Do your check yourself. We'll start next time on the focus at the bottom of page 12. Remind me, we've already done the focus at the top of page 13. All right, you got homework? You got everything? We'll see you Wednesday. I'll try to have your quiz ready on Wednesday. Yeah. I'm sorry?
Did you keep my test?
Did I keep it?
Yeah. Because we couldn't meet Friday. We were busy. We couldn't meet Thursday. You said you was going to keep it somewhere.
Okay.
Because I'm actually on bed rest.
Oh, I'm sorry. Okay. You want? Okay. Okay. It's what you're saying is you haven't taken it, right? Okay. When do you want to take it? Today. That's fine. You want to take it now? Okay. I'll need to put you in a different classroom because I've got a class coming in here. Is that okay? Yeah. So I've got it right here. If that's what you're asking, I didn't understand what you're asking. Yes, ma'am.
Wednesday I won't be here because my mom having surgery.
Oh, I'm sorry.
Some kind of excuse.
And what?
Bring an excuse.
Oh, you don't need that.
Okay.
Yeah.
All right.
But just if you come get your quiz as soon as you can.
We'll get my quiz. Okay. Will you be here all day Wednesday?
I'll be here all day. Well, all day Wednesday up until 4 o'clock. At 4 o'clock, I have to go to the Birmingham East Campus for a 4:30 class.
Okay. Either if I'm not done before 4, I just come to Birmingham and get it.
Okay.
I still live close.
So bring the quiz with me to Birmingham.
Yes,
Okay.
sir.
All right.
Okay. Thank you. And I'll just email you and remind you.
Okay.
Okay. Thank you.
Yeah. Which also reminded me, here Drew was here and I forgot to give him his quiz. No, that's not his quiz. Some people have quizzes turned in, but I didn't turn. Riley was here and I didn't give her hers. Zaria was here. That's you. Okay. There's your quiz. And then Gary wasn't here. Okay, now the test. Okay, I know you don't want the key, so there we go.
But I've been on bed rest since last Wednesday.
Oh, I'm sorry.
It's here.
Yeah. I hope everything goes well.
You have a great test.
Let's see. Did I?
What classroom you want to go to?
Yeah, let me get with you. I'm 2 away from yours. Sorry about that.
No, it's fine. I just didn't see it on Blackboard yet.
Right. Yeah, well, no, I haven't got any of them or many of them on Blackboard yet.
It's
Okay, I'm going to go on and pause it or end